Lesson 16, day 2, elimination. The only difference today in prior to yesterday's lesson is actually you're going to need to take step 1, and that's write the system of equations so that like terms are aligned. Some of the like terms will not be aligned today, so we need to make sure that they're aligned. And then you can go ahead and start in on steps 2 to 5, which you worked with yesterday. So looking at our first example here today, notice that it is not the first thing that we need to do is actually do our distributive property here. So I'm just going to go ahead and slide over this first example here, 7x plus 10y equals negative 29. Next I'm going to distribute, giving me negative 10x, negative 10y, and a positive 50. Once we have that, we can go ahead and look at our paper and notice that there is elimination happening, and that's with our y values here. So when we work down our paper, we wind up with 7x take away 10x is negative 3x. Our y's would cancel out, and negative 29 plus 50 is going to give us 21. Next step, get x alone, divide both sides by negative 3, and we have x equals negative 7. Now you can use negative 7 and substitute into either one of the equations above here that they give us. I would recommend using these two equations versus this equation. Reason being is you have your distributive property that needs to take place here. So I'd substitute back into one of the original equations. I'm going to go ahead and use this top one here. So 7 in for x is 7 plus 10y equals negative 29. We have 49 plus 10y equals negative 29. Subtract by 49. And we wind up with 10y. And actually, sorry, I had a negative 7. So that negative 7 goes up there. This is actually negative 49. And then I would need to add 49 to both sides. So my mistake there. When I do that, I have 10y equals 20. And then I would divide both sides by 10, giving me y equals 2. So again, that's an order. That's our solution here. Negative 7, 2 is our solution, and that is the point of intersection. Jump to our next example, example 4. Again, 6x minus 15y equals negative 6. Do my distributive property here. When I distribute, I get negative 6x. 3 times 5y is going to be 15y equals 3 times 2 is 6. And if you look here, everything is actually going to cancel out. Cancels. 0 equals 0, which is a true statement. So therefore, these two problems, if you actually put them in a slope-intercept form, you would find that they are the same line. So this has an infinite number of solutions. Whatever you put in for x, you'll get something out for y. We'd see that it's equal. So infinite number of solutions. Last example. In this example, we're actually going to have to write two equations. Remember, when you write equations here, kind of think of it as a teeter-totter. So let's find the numbers described in the situation. Two numbers added together equals 14. There's my two numbers added together equal 14. Well, here's my two numbers. We don't know what those numbers are, so we use variables. X plus y equals 14. There's one equation. And their difference is 8. So the difference of these two numbers. So x minus y equals 8. There's the difference of them. There's our two equations. Now we can go ahead and do our elimination here. So actually what's eliminating in this problem are your y values. X plus x gives us 2x equals 14 plus 8 is 22. Divide both sides by 2. And we find out x equals 11. Now we need to go ahead and plug it back into one of our equations above. So if I use this first equation here, in for x is 11 plus y equals 14. Get y by itself, minus 11 from both sides, and we find out y equals 3. So another way you could double check it is we already know from this equation here that we get 8, so you plug it in. Well, x is 11 minus the 3 is going to give us the 8, so it also checks out. So our solution, or our two numbers, in this case are 11, I should say, and 3, because it doesn't have to, we don't have to use variables x and y here, we can use any variable. But this concludes our lesson here on Lesson 16, Elimination, Day 2.